All right, so what we're going to cover today is we're going to cover how to name things. We're going to cover how to name ions, and then we're going to look at how to name compounds. We're going to look at something called ionic and something called molecular compounds. Okay, so we're going to start first with ions, and then we're going to talk about compounds. So this is the idea. If you remember before, we covered classification of matter. We said that matter is divided into two groups. You have your pure substances, and then your mixtures. You remember that from last time. And then your pure substances were divided into your elements, you remember, and then your compounds. All right, so today we'll look at how to name compounds. We'll look at how to name two types of compounds called ionic and molecular. I'll distinguish the difference between the two. But we're going to first start with going back to elements. If you remember when we first did how to do certain calculations with the atom. For example, let's say I have nitrogen and the two values are N, 7, 14, right? You remember this is the atomic number and this is the mass number. And the atomic number is the same as the number of protons. And this is the same as the number of protons and the neutrons. You might remember then we also said, for instance, if this is neutral, then that means the number of protons is equal to the number of electrons. So we could say that nitrogen, when neutral, has 7 protons, but it also has 7 electrons. Okay, so what we're going to do today is we're going to say, what if they're not neutral? So what if the number of protons does not equal the number of electrons? Well, in that case, your element is an ion, okay? So an ion is something where the number of protons does not equal the number of electrons. That's what we're going to look at today. And we're going to look at still how to do some simple math with it, but also how to do some naming of ions, okay? So let's take a look. So here is a sheet. Now, these 3 sheets that we're going to work on, they're all in the chem folder, okay, with the solutions. So there's a sheet on ions, there's a sheet on ionic compounds, and there's a sheet on molecular compounds. There's also the answer key too, so you can take a look at the answer key because I don't think we're going to do all of them, but we'll do most of them, and you can do the rest, okay? Okay, so here we go. Now, we're going to look at ions first, okay? Okay. So we're going to break up, we're going to classify ions into basically 2 types, the positive ones and the negative ones, okay? If you remember from your periodic table trends, the metals, things on the left side of the staircase, metals, they want to lose electrons. Like, for instance, if you remember members in the first column, something like lithium. Lithium, if you recall, has 2 electrons in its first ring and then 1 more in its outer ring. And because it's almost empty, metals, in this case lithium, wants to lose that 1 electron to make it stable. So what you'll see here is that metals are going to want to lose electrons, whereas the things on the right side of the periodic table, the nonmetals, are going to want to gain electrons. So if you remember something like fluorine, fluorine has 9 electrons when it's neutral because it has 9 protons. So it would have 2 electrons in the first ring, and then in the second ring it would have 1, 2, 3, 4, 5, 6, 7. So it would need 1 more to make it full and be stable, right? So there are going to be things that are going to want to gain electrons. That'll be on the right side. And things that are going to want to lose electrons. That'll be in the left side. Those will be your metals. So, for instance, fluorine wants to gain 1 electron, whereas lithium wants to lose 1 electron. Okay, so mathematically, this is easy to calculate. If something gains 1 electron, what you just see is a little symbol, a little negative symbol with no number. Because a no number means 1, okay? So chlorine, if you see this symbol, that means it gained 1 electron. All right, so no number means 1, okay? Otherwise, you'll see a number. For example, here you'll see a number 2. That obviously doesn't mean 1. So we're going to come back to that in a second. So fluorine wants to gain 1 electron. So how many electrons does it have? This math is very easy. We know that when it's neutral, it has 9. So if it gains 1 electron, it has 10. 9 plus 1, right? 9 plus 1 gives you 10. So it has 10 electrons. If it has 10 electrons, then it would be the same as the 10th element in the periodic table, which is neon, okay? Which is neon. All right, now, if I look at the next example, oh, sorry, I forgot to mention something about negative ions. So the negative ions are a little bit trickier than the positive ones. And the reason for that is because you actually have to change their name. Okay, I should mention this is very, very important. So what happens when an atom picks up an electron and becomes negatively charged? Now it's an ion. Remember, an ion is something that does not have the same number of electrons and protons. So if it picks up electrons, we change its name. We add an IDE ending to it. So instead of it being fluorine, now it becomes fluoride. So if you come across an ion, and you'll notice that has an IDE ending on it, then it's negatively charged. Now I'm saying that now, but they're going to be always never as easy as it sounds, okay? So if it's an ion, this is important, okay? If it's an ion and you see an IDE ending, that means it's negative, okay? It's very important. The reason why I'm saying that is because you can come across IDE endings, but it might not be an ion. So that can make it a little bit complicated, but that you'll deal with in grade 10 or grade 11. So let's not worry about that right now. Okay, so let's look at the next example, all right? So the next example is element number 53. So element number 53 is, I'm saying it's iodine. Let me just double check. Yeah, it's iodine. So element number 53 iodine. So its symbol is I, right? That's the symbol for iodine. Now, it has 53 protons. So normally it would have 53 electrons, but you can see that it actually has 54. So it also gained 1. Now, it would have the same number of electrons as element number 54, which is Xe, or xenon. Okay. Now, because it gained an electron, we don't call it iodine anymore. If it picks up an electron, we now call it iodide. All right. You'll get a hang of the naming. It eventually comes to you when you do enough of this. But this is only, like, keep in mind, we're not going to do a lot of this. So we're just going to do a little bit of this so you just get a taste of it. But we're not going to go crazy into detail in terms of like naming all different types of compounds, all right? All right, so let's look at the next one. The next one is, so this has got 16 protons. So obviously it's element number 16. So on my periodic table, element number 16, oh, sorry, I forgot to put the symbol. So if iodine gained an electron, then its charge would be negative. Now we don't put the 1, because you don't need to put the 1, okay? Okay, now everything is complete. Let's look at the next one. Look at number 2 now, okay? So element number 16 is sulfur. Okay. It says it gained 2 electrons. So if it's neutral, it has 16 electrons because it has the same number as number of protons when neutral. But it gained 2. So obviously we have to add 2 more electrons. So it has now 18. Okay, so it has 18 electrons. Okay. It would have then the same number of electrons as element number 18, which is argon. Again, if it's negatively charged, we now change its name to an IDE ending. Now, here's where it might be a little bit tricky. So it would kind of sound weird to say sulfuride. That sounds kind of weird. So in this case, it would just simply be sulfide. Eventually, you'll get used to the naming. Okay, sulfide. Now, if it loses electrons, that's actually easier. You don't have to change the name. Okay, so things that lose electrons, like the metals, the name does not change. So, for example, potassium. Potassium is element number 19. So that means it has 19 protons. All right. Now, I forgot to put the symbol. So sulfur gained 2 electrons, so it would have a charge of -2. So what you'll notice is the number goes in front of the charge. So the 2 goes in front of the negative charge. That means that it gained 2 electrons. Okay. All right. Now row 2 is complete. So let's look at row 3. Potassium. Element number 19, which means it has 19 protons. Now, it normally has 19 electrons if neutral, but it said that it lost 1, so it would have 18 electrons. So therefore, it would also have the same number of electrons as argon. Now, what would its symbol be? Well, potassium is K, but it lost 1 electron. So it wouldn't be negatively charged, it would be positively charged. And you don't need to put a number in because it's just 1. We'll look at the next row. And the next row is the symbol is Ca. So we know that's calcium. Okay. Again, remember, if it loses electrons, you do not change the name. So calcium is the 20th element, so it normally has 20 protons. Not normally, always has 20 protons. It would normally have 20 electrons. But because it's +2, that means it lost 2 electrons. So it would have 18. Again, having the same number as argon. So you hopefully starting to see a trend here, okay? Let's look at the next row. The next row is element number 35. So element number 35 is bromine. That's what you would call it, but because it's an ion, we don't call it bromine, we call it bromide, all right? Because it picks up, you can see it picked up 1 electron. How do we know it's 1? Well, it is in the second last column, the halogens. We know that they want to gain 1 electron. So if you notice that bromine is element number 35, so it should have 35 protons, but also when neutral, 35 electrons, but it has 36. So we know it gained 1 electron. You'll notice that iodine gained 1, fluorine gained 1, because they are all in the same family, right? They're all in that second last column called the halogens. So what would its symbol be? Well, it would be the same as the symbol for iodide, and the same as the symbol for fluoride. It would be a Br-. So it would have the same number of electrons as krypton, Kr. Okay. If I look at the next one is strontium. So strontium is, trying to find that on my table here. is number 38. This is element 38. So strontium. Now remember, positive ions, the name does not change. That's easy. So it's element number 38. We know that it's in the second column. Second column, it wants to lose electrons, right? So it wants to lose 2 electrons, just like calcium. So strontium and calcium are actually in the same family. So if it loses 2 electrons, it would have 36. Now, how do I know it lost 2 electrons? Well, because it's in the same family as calcium, but also because it actually says +2 here. So I know it lost 2 electrons. So it would also have the same number of electrons as krypton. Okay, now, if I look at the next one, hydrogen. Hydrogen actually comes up here and here. So let's actually address it, because hydrogen is a funny one. Hydrogen is not really, it's not a metal, but it is in that same group as the alkali metals. So it can actually do one of 2 things. It could actually lose its electron, because hydrogen only has 1 electron. So it's got a nucleus, right? And it's got that 1 electron. So it could either add 1 to fill it up, or it can get rid of 1 to become empty. In both cases, it'll be stable, right? So if it loses, we know the name doesn't change. Let's say it's hydrogen. So it's element number 1, which means it has 1 proton and 1 electron. This means it lost 1 electron. So now it has 0 electrons. So it lost 1 electron. You notice there's a dash here because there's nothing on the periodic table that would have 0 electrons that we can compare it to. But if you look at number 12, you can see number 12 has a negative symbol. So that means that instead of losing that electron, it normally would have 1, and it gained 1 more. So now it has 2. So it gained 1 electron. So now it has the same as helium. And like we said, if it gains electrons, we have to change its name. So if I say, like, for example, hydrogenide, that would sound very, very weird. So what's actually called is hydride. Okay, there you go. Okay, let's do number 8. So number 8 is element number 8, coincidentally. This is the number of protons, so it's element number 8. So that's oxygen. So we know it's oxygen. So we're just going to write down oxygen for now, but we're going to change its name. So it says that it gained 2 electrons. So that would mean it has 10, because it normally has 8, but it gained 2, so that's 10. So it had the same number of electrons as neon. So that means that it would be O2 minus, because it gained 2 electrons. And the name has to change to oxide. Again, it would sound kind of weird to say oxygenide. So we would say oxide. Okay. If we look at row number 9, row number 9 is element 12. Element 12 is magnesium. So its symbol is Mg. Now, it normally has 12 electrons, because when neutral, it has 12 protons, so therefore it has 12 electrons. But this is lost 2, so 12 minus 2 would be 10. So it also have the same number as neon. And therefore, because it lost 2 electrons, its charge would be plus 2. There's a question in the chat. So the only time we change the name are the ones that pick up electrons, okay? That's when we change it. So for compounds that pick up electrons, the name changes to an IDE ending. All right. So that way, you know, if I say for example, that it's not sulfur but sulfide, that would mean that it picked up electrons. Okay. Now you'll see actually that could actually mean something else. So here's what I can tell you for sure. If it loses electrons, the name doesn't change. If it gains electrons, the name changes to an IDE ending. All right. Okay. Okay. So let's take a look at aluminum. I'll do aluminum, and then you could do the last 5. All right. Actually, the last 4, because we did hydride already. So here's aluminum. Aluminum is, it says it has 10. This column is the number of electrons. So it says it has 10 electrons. Now, aluminum is element number 13. So if it's element number 13, that means it has 13 protons. If it's neutral, it should also have 13 electrons, right? But it doesn't, it has 10. So that means it lost 3. Again, if it has 10 electrons, it would be the same as neon. Now, if it loses 3 electrons, how do you write that? Well, we know that the plus sign means that it's lost electrons, and we just put a 3 in front to represent that it lost 3 electrons. Okay? So to recap, if you see a symbol and you see a negative, we know that it gained electrons. If there's no number, it gained 1. If you see, for example, something like this, 3 minus, that means it gained 3 electrons. If we see a positive, we know it lost electrons. If it's no number, like this, we know it lost 1 electron. But if there's a number in front, like 3, that means it lost 3 electrons. Okay, so this is how you do naming of ions, right? Just to go back, this is how to name ions. And again, an ion is something that the number of protons does not equal the number of electrons. Okay, so that's what an ion is. Okay. So that leaves you with just 4. You could do number 11, 13, 14, and 15. You could try those out. Okay, again, there is an answer key. So here's the thing. What we could do is we can now tie this in with the next topic, which is ionic compounds. Okay, but if I look at this sheet, there's stuff in here that we're not going to do. So I'm going to tell you what we're not going to do. We're not going to do this stuff here. Okay. Oops. So this stuff here that has to do with mass, we're not going to worry about that. Okay. So you could ignore it. We're just going to focus on the naming. All right. That's all we're going to focus on is the naming with things that are ions. All right. So why would something want to become an ion? Why would it want to gain or lose electrons? Well, because this goes back to Bohr-Rutherford diagrams. If an element is not stable, it's because the outer shell is either almost empty or almost full, right? If it's almost empty, it's going to want to lose electrons. If it's almost full, it's going to want to gain electrons. So what would happen then is something that wants to lose electrons would want to pair up with something that wants to gain electrons. Let me give you an example. Let's say we have lithium, okay? So lithium I'm just going to draw the outer shell, okay? In the outer shell of lithium, it has 1 electron, okay? It's going to draw the outer shell, all right? Now, if I look at fluorine and I draw only fluorine's outer shell, it has 1, 2, 3, 4, 5, 6, 7 electrons. So it wants to gain 1. From the previous sheet, we know fluorine wants to become negatively charged, okay? And lithium wants to become positively charged because it wants to lose that electron. Okay, so what happened then is lithium and fluorine would pair up because they can satisfy what the other one wants, right? So lithium wants to lose the electron and fluorine wants to gain the electron. So that's a perfect match. So if that happens, you get something called an ionic compound. All right. So this is going to happen between a metal and a non-metal. All right. The metal is going to want to lose the electrons, and the non-metal is going to want to gain electrons. So they'll pair up and they'll form something called an ionic compound. Now, what we could do is we can learn two things. We can learn how to name them, but we can also learn how to write their formula. Okay? It's actually quite easy. The naming is actually just a continuation of the previous sheets. We know that things that lose electrons, their name doesn't change. Things that gain electrons, their name changes to an IDE ending, right? So let's look at our first example. From the previous sheet, aluminum actually wants to lose 3 electrons. It has 3 electrons. It wants to get rid of them. It wants to be positive 3. Chlorine, if you remember, has, just like fluorine, has 7 electrons and it wants 1 more. So it wants to be -1. So they can form an alliance. They can come together and they can form a compound called aluminum chloride. Right? Think of the name of this compound, aluminum. You'll notice the metal's name is the same because metals lose electrons. Their name stays the same. But chloride, why its name changed? Because it picked up electrons. So let's actually just do the naming for a second, okay? So if I put sodium and fluorine together, then that should be something called sodium fluoride. Right, metal's name stays the same. The negative ion, you see name changes, right? The next one would be lithium oxide. So what we're doing is we're just putting together what we did in the previous sheet. If beryllium and iodine want to get together, so beryllium wants to lose electrons. It is element number 4. So it actually wants to lose 2 electrons, and iodine wants to pick up electrons, 1. So that would be called beryllium iodide. All right. So if I look at the next one, calcium and nitrogen. So that would be, if they form an ionic compound, that would be called calcium nitride. Magnesium and sulfur will be called magnesium sulfide. If I look at Rb, rubidium, and bromine, that would be called rubidium bromide. So you'll notice the only thing that changes, again, is that negative ion, which is definitely the one that's not the metal, right? So the metal stays the same, the other one changes. The last one would be barium phosphide. Okay, now that's how to name them. But there's also a section here that says what is the formula? So that's actually very, very easy, because let's think of it this way. We know that lithium wants to lose 1 electron and fluorine wants to gain 1 electron. So 1 lithium and 1 fluorine would help each other out. So we can determine the formulas based on their charges. It's really, really easy to do. We know lithium wants to lose 1 electron, and we know fluorine wants to gain 1 electron. So we just need 1 of each to form a compound. So lithium and fluorine would form a compound called lithium fluoride. Okay, hopefully we know how to name them. The metal stays the same. Negative ion changes. And you just need one of each because they would help each other out. Now, what if it's something like aluminum and chlorine? Okay, so how do you figure that out? Well, can't have one chlorine making aluminum happy. And I'll tell you why. Because if I look at the way, let's say we draw it out, okay? Now you don't need to do this. So I'm going to show you the shortcut. But if I draw like aluminum, let's say aluminum, I just draw the valence shell, okay? So aluminum, I'm just going to draw the outer ring of aluminum. It has 3 electrons, okay? Just the outer ring. Now, it wants to lose those 3 electrons. That's why it wants to become positive 3. Now, chlorine, if I just draw the outer ring, remember this is just the outer ring. So here's the nucleus, here's the outer ring. Chlorine has 1, 2, 3, 4, 5, 6, 7, right? So just like fluorine, chlorine wants 1 more electron. So it would like to take aluminum's chlorine and put it right here. And then chlorine would be happy, right? Because now chlorine has an outer shell that's full. So chlorine would be happy. But the problem is aluminum is still not happy because 1 chlorine took 1 electron, but it still has 2 it wants to get rid of. So obviously it would need to pair up with more than 1 chlorine. It would need to pair up with 3. So there's an easy way to figure this out. It's called a crossover rule, okay? What you do is you look at the charge of the ion and you just flip the number. So for example, aluminum wants to be +3, chlorine wants to be -1. So what we do is we look at the number. So this is the number 3, and we know this means 1. So we just simply flip the number. We put the 1 for aluminum, which means we need 1 aluminum, and we need 3 chlorine. So you would write it like this, AlCl3. So let's do an example together. So for example, sodium. We know sodium wants to lose 1 electron, so it wants to be +1. And we know fluorine wants to gain 1 electron and be -1. Now, what does this mean? If there's no number, that means 1, right? This means 1, this means 1. So because the number is the same, the formula for this, I'll just write it in here, would just simply be NaF. Just 1 of each. That's good. But if we compare it to the next one, okay, well, lithium also wants to be +1, but oxygen wants to be -2. Okay, so what does that mean? That means, remember, this means 1, right? That means I would need 1 oxygen, but I would need 2 lithium. So how do you write that? We know it's called lithium oxide. So how do you write it? Well, you write like this, Li2O, because I need 2 lithium and 1 oxygen. Let's do the next one together. Let's do Be and I. All right, so Be and I, beryllium iodide. So beryllium is in the second column, so it wants to be +2. Iodine wants to be -1. So again, that means 1, right? So what does this say? This says I need 1 beryllium, but I need 2 iodine. So how do you write this? Well, 1 beryllium would just simply be Be, and 2 iodine would be I2. Let's do 1 more together, and then you could do the 3 that we don't finish, okay? So let's do Mg and S. So we know it's called magnesium sulfide. So we know magnesium wants to be +2 because it's in the second column. And sulfur is in the same family as oxygen, so it also wants to be -2. Now, according to what I said, you flip the numbers, right? So if I flip them, well, they're both 2 and 2. So that would be Mg2s2. But here's what we can do with ionic compounds. If the numbers are the same, or if they're divisible by something, then we could reduce it. So I noticed that Mg2s2, the number 2 is both divisible by 2. So what I could do is I can actually write it as, I'll write it down here, okay? I can write it as just Mgs. Now, why does that make sense? Because if I draw magnesium, so let's say this is magnesium, right? And I just draw the valence shell. So it has 2 electrons, 1, 2. Now, sulfur has 6, just like oxygen. It's in the same family. 1, 2, 3, 4, 5, 6. So what does sulfur want? Sulfur wants 2 electrons. You can see that it would want 1 more here and 1 more there. So magnesium wants to lose 2 electrons. So one magnesium atom would be able to make 1 sulfur atom very happy, or we can say 1 sulfur atom would make 1 magnesium atom very happy, because 1 magnesium atom could donate 1 electron and 2 electrons, and then they'll both be happy. What does that mean? It means they just need 1 of each. So with ionic compounds, if the formula is, if you can reduce it, then you should reduce it. So for example, if I have a formula like this, say it's X4Y2, and it's ionic, then I could reduce this to X2Y because they're both divisible by 2. All right? So you can try this one, and this one. All right? Try them out, and then we can take them up on Wednesday. So those are ionic compounds. All right? Any questions so far? So we covered ions, how to name them, right? How to name, and then obviously you can see the connection between this sheet and this sheet. Now, the last sheet, because if you remember when we did the periodic table, as we start to move towards the middle of the table, we have a bit of a problem. What if we have things where we're not really sure that they want to lose or gain electrons? Maybe instead of losing or gaining electrons, they do something different. They share electrons. That's another possibility. And you'll learn more about this in senior chemistry, probably like maybe a little bit, maybe in grade 10 or 11. Definitely in grade 11 for sure. Sometimes elements will share electrons. So instead of taking or giving electrons, they share them. If they do that, if they share electrons, then they're called molecular compounds, okay? Or covalent compounds, same thing. Again, with this sheet, we're not going to do this, so don't worry about figuring out the mass of this stuff, so don't worry about that, okay? I just want to focus on the naming. Now, this one, I'll be honest with you, is maybe on the one hand a little bit trickier, on the other hand maybe a little bit easier. So just like the previous example, the first thing in the compound, its name stays the same. You'll notice that in all these examples, the only one where the name changed is the second ion, and that's because it's negatively charged. So I should have mentioned this to you. When we write an ionic compound, you always put the metal first, and then you put the non-metal second. So by doing that, you'll notice the compound always starts with the name of the metal, which doesn't change, but it ends with the name of the non-metal, which changes to an IDE ending, right? You notice that in all the examples. If it's molecular, there is a similarity. The first element's name stays the same. The second element's name changes to an IDE ending. So for instance, C and O would be called carbon dioxide. All right, so it would, again, you'll notice the carbon stays the same, and the oxide, that one changes, right? So it's not called carbon oxygen. Now, what makes this a little bit tricky is the use of certain prefixes, okay? And there's only a few that you're gonna have to know. You'll probably do more in senior chem, but the few would be mono, di, tri, tetra. I don't know if you need to know any more for here. I think we could just do that for now. There are more, but let's just do those. Let's just keep it really, really simple, okay? There are more. There's penta, there's hexa, and you'll see the trend, okay? Mono means 1, di means 2, tri means 3, tetra means 4, penta means 5. Okay. So if you see prefixes in your compound's name, then that means it's a molecular compound. So this is a compound where the elements are sharing electrons. So that's different than what we just did. In the previous example, one accepted, one gained electrons, one lost electrons. Here, they share electrons. Again, I'm going to say this, you're not going to learn how to determine that until grade 11. There's actually a way you can figure, well, how do you know if they share? How do you know if they don't share? There's actually a way to figure that out, okay? We're not going to do that in grade 9. I just want you to know how to name them and how to look at some simple formulas. So if I see this first example where it says it's CO2, I notice that there's 2 oxygen. So what I would say is I would call this carbon dioxide. This is 2 oxygen, okay? So what we're gonna do is we're gonna do this sheet together because this one is a little bit trickier, okay? So carbon and chlorine can actually form a compound that will look something like this, CCl4. Now that would then be called carbon. Notice this is a 4 for chlorine, so we call that would be tetra chloride. Okay. The next one. So the thing about molecular compounds is they can be tricky because we don't really know sometimes what the formula is based on the number of electrons they have. In the previous example, it was really easy. I could use that rule that I showed you, where if I know the charge of my ions, I can just flip the numbers and figure out the formula. So it's very, very easy. But molecular compounds are trickier because, I'll give you an example. I could get carbon dioxide, that's true, but I can also get something like this. Now, what would that be called? Well, that would be called carbon. And you see how there is just 1 oxygen? That would actually be called carbon monoxide. And you should probably be familiar with that one because that's the one that's very, very dangerous. You have carbon monoxide detectors to protect you. So I would never ask you to predict the formula of a molecular compound because there's actually some variation with the formulas. So I just want you to know how to, if I give you the name, you should be able to tell me the formula, or if I give you the formula, you should be able to tell me the name. So I would give you one of those 2 things. So for example, if I gave you this SO2, right, then you should be able to tell me that would be called sulfur. And see how there's a 2 here? And 2 is di. It would be called sulfur dioxide. If I look at the next one, if I say to you something like this, nitrogen trihydride, you should be able to tell me that it would be 1 nitrogen and 3 hydrogen. Okay. Like for example, like this one, because molecular compounds are tricky, this could be NO. So that would be called nitrogen monoxide. But it could also be, there's other forms of it. Like I've seen this, N2O5. Obviously that would be called something different. Let me erase this. If it looks like that, that would be called dinitrogen. Why di? Because there's 2 nitrogen, right? And di means 2, right? So it'd be called dinitrogen pentoxide. In this case, you drop the A because you can't have 2 vowels in a row. But you're not going to come across too many of those. For example, this one, if it's written like that, would be called silicon dioxide. Let's say we have this. Carbon tetrafluoride. Then its formula would be CCl, oh, fluoride, not chloride. Why CF4? Well, because, and I hope you're noticing the trend too. If you don't see anything, if there's no prefix, then we know it's just 1, right? So carbon, there's nothing in front of carbon, so it's just 1. But it says tetrafluoride, so obviously that means it's 4 fluorine. So the next one, there are various forms of combining oxygen with phosphorus. So for example, here's one version. So that would actually look the same as the example we did over here. So that would be diphosphorus pentoxide. So you can see that there are some rules to this. It's trickier because there's some variation with the way you name the molecular compounds. Ionic compounds are always easier to predict. But I guess what's nice about the molecular ones is because the prefix, if you're given the prefixes, you know what the formula is, right? So in terms of what I expect in grade 9 is just if you see the name, you should tell me, you should be able to predict the formula. But if you see the formula, you should be able to predict the name. Okay, I'm not going to ask you to, for example, from scratch. Like if I just say oxygen and nitrogen, give me a. I'm not going to expect you to know like the different types of compounds that could form. All right. There's a question in the chat. I wouldn't worry so much about this. Let me actually stop the recording and I'll answer that question. Okay, hold on.